As Marcus said, my name is Pandy Knight. I am super excited to be here. Pardon me. So a little bit about me. You may know me as the Automation Panda. I'm an engineer who focuses on testing and automation. I've been in the Python community for a couple of years now, and I love it. And so I'm super excited to be here today for this very awesome workshop on awesome web testing with Playwright. Right now, I am working as a developer advocate at Applitools, where we focus on automated visual testing. The way it works is, I'm sure you've probably seen some awkward visual bugs where there's some horrible blunder or overlapping text on your website. We help you with that. We have visual AI tools that can go into your automated test scripts and just take visual snapshots, capture a baseline, you capture checkpoints along the way, and you do visual comparisons. It's really cool stuff. I also lead Test Automation University, which is the most awesome online platform for completely free courses on testing and automation and all that good stuff. So check it out, testautomationu@applitools.com. If you want to learn more about Playwright or Selenium or any other testing tool out there, TAU is the place to go. A little bit more about me personally. In this picture, you see two of my favorite things. You see my 1970 Volkswagen Beetle and my little puppy dog named Suki. Here's a bigger picture of her. She is a purebred lilac French bulldog. I wish I could have her on camera here, but she would probably be very naughty and distracting, and we wouldn't actually get any Python coding done. But yeah, so be sure to like on Twitter and everything. If you follow me on Twitter, I'm sure you'll see more pictures of her. She's also on Instagram, Suki the Frenchie. Unbearably cute. I just want to look at this for another second. Okay. Enough of that. Let's talk about Playwright. So what is Playwright? I'm guessing if you came to this workshop, you probably already know a little bit about what it is, or maybe just like, oh, Andy Knight's talking about something, let's go listen. Playwright is a web testing framework. It is an open source end-to-end web testing framework. What that means is it's manipulating your browser. It's automating those browser interactions, everything like clicks and entering text and scraping things and navigation. It is an open source test framework for doing those kinds of things. It's also come from Microsoft. It's developed by the same group within Microsoft that has brought you Visual Studio Code and TypeScript and those other kinds of developer experience types of tools. What's really nice about Playwright is that it also has implementations in multiple languages. Today, we're going to talk about the Python one, of course, but it also has bindings for JavaScript / TypeScript, Java, and C#.NET. They keep all of those language implementations fairly consistent. So if there's features in one, there's most likely features in all of them, which personally I really like, because in my job as a developer advocate and a test engineer, I'm hopping between languages all the time. And finally, you may be asking, well, Andy, I know you've talked so much about how you love PyTest in the past. Is Playwright going to replace PyTest? No, Playwright integrates with PyTest. So PyTest is there to kind of structure your test case functions and to be the runner for you and to tally up all the results at the end. Playwright comes in and gives you a really, really good library for those browser interactions, like I said. And so there's actually a plugin for PyTest for Playwright where they come together and work nicely that we're going to use today. Now, when I say end-to-end testing, I want to clarify what that means. As I said before, Playwright is designed for end-to-end web testing. So not that we're going to go in and test little functions and methods or snippets of JavaScript code. We are going to be testing full web applications being rendered within a browser. And Playwright is going to be sending the browser interactions to that live browser. It uses Chrome debug protocols and the other browsers debug protocols to do this. It's pretty cool stuff. Also, if we get to it at the end of today, Playwright also has support for API interactions as well. So not only can you manipulate a web app through its front end, you can also reach around to its back end. I say all of this to clarify that Playwright is not what we call a unit testing framework. Unfortunately, especially within the Python community, I've seen when people talk about testing frameworks, they almost just slip in unit testing. And it's not all test frameworks are meant for unit testing. Not all tests are unit tests. In my book, unit tests are tests that explicitly cover code. They cover implementation. You're checking to see if the way you wrote a function or a method or something is correct. Whereas a feature level test or an integration or end-to-end test is testing, does the feature or product or behavior as a user would use it turn out correctly? And so Playwright is not a unit test framework. It is that end-to-end. It's that UI kind of framework. It's testing to make sure that the things that you developed in your web app are actually working as you intended. Now, you may also be wondering, hey, Andy, we talked about Playwright being an end-to-end framework. It's not a unit framework. It's working together with PyTest. What about Selenium? Selenium WebDriver has historically been the top browser automation tool. It's been around since, gosh, more than a decade ago. It's the mainstay. It's still, by all indicators, the most popular in terms of usage. So why would we be talking about Playwright instead of Selenium WebDriver? Well, Playwright has a number of advantages over Selenium WebDriver. First and foremost is speed. Playwright is a lot faster than Selenium WebDriver. It can do this. It achieves faster speed in a couple of ways. First of all, they use something called browser contexts, where you can kind of reuse a browser instance and just get private sessions. We'll look at that a little bit later. It also uses browser projects instead of full browsers. And it's using debug protocols instead of the WebDriver protocol. So there's a lot of nifty optimizations that can happen. What I've seen is that tests can be anywhere from a few seconds faster to a fraction of the time a Selenium WebDriver based test can take. Some other big advantages of Playwright: easier setup. With Selenium, you have to install these WebDriver executables on your path. Playwright is one command that goes boom and it's there. Playwright has automatic waiting for you. It's smart. Waiting or improper waiting is one of the main reasons why black box tests become quote unquote flaky. You may have a poor impression of API or web UI tests because they might randomly break, or they're slow, or they crash, or those kinds of things. A lot of that flakiness comes not from the nature of it being web UI or API, or the nature of you using a particular tool like Selenium. It comes from the fact that you don't have proper waiting in place. And so the page will do something, or the page won't have done something by the time you send an interaction to it, and there's that break. So Playwright has baked in automatic waiting for you, which is really, really nice. You don't need to make it explicit. It just happens. Playwright's assertions are also web-centric. So you don't need to get a value from something and then do an assert call against it. Playwright offers an expect function and specific conditions that go along with that, so that it's smartly checking the web elements for you, until it meets a certain condition, which is the way you want to be with web testing. And finally, Playwright out of the box offers a lot of tracing. You've got screenshots, you've got video recording, which is something Selenium doesn't natively do. You've got a full execution trace. You've got a viewer for these traces. And so we're going to look at some of those things today. All in all, that makes Playwright feel like a more modern, a more I wouldn't say mature, but a more modern, a more comprehensive framework than just Selenium WebDriver, which in my book, I would call a tool, not a framework. Now, I do want to give an asterisk here. Both Playwright and Selenium are open source projects, meaning you can go to the GitHub repos, you can look at the code, you can even contribute, all that kind of good stuff. But Selenium uses open standards and open governance. So what does that mean? Selenium WebDriver is based on the W3C WebDriver protocol. It's an open standard that all browsers are supposed to conform to. It was a hard-won battle within the testing and QA space to get that in place. I don't want to go through the history and all that right now, but pretty much every single major browser is almost guaranteed to follow the WebDriver protocol so that you can use that protocol for browser manipulation. That's what Selenium WebDriver is based upon. So that's what open standards mean. What does open governance mean? Open governance means that the Selenium projects, which includes the Selenium WebDriver implementations, as well as a tool called Selenium IDE, which is like a visual builder, and Selenium Grid, which is a scale-out infrastructure for distributing browser test execution across a whole cluster. The Selenium project is managed by open governance, meaning there's different people, there's different companies, there's different roles and ways to contribute, and it's all open. It's not controlled by like one company or one entity. The Selenium project prides itself on this three-pronged thing: the open source, open standards, open governance. Playwright is open source, but since it is a Microsoft-based project, it doesn't have that open governance in the sense of multiple different people coming in, even though you can still contribute to Playwright and kind of help with the direction and that kind of thing. Is still, controlled by the Playwright team at Microsoft. And Playwright, like I said, uses those debug protocols. So it's not like it's an open W3C standard, at least not yet. Now, I bring this up because this is currently a hot topic within the testing and automation space. And I have kind of put my foot in my mouth at certain occasions on this. So in the Python community, this might be the first time that you've seen or heard of this kind of thing, but know that this is slightly controversial. There are some folks who are like, no, I will only use Selenium because it has the open standards, open governance. There are other people who are saying, well, I just want what I consider to be the best tool out there, free market of ideas, let the best tool win. I don't want to comment like on what side I fall on that. Personally, I like both projects. I've used both projects. I just want to call this out so that you're aware of these things. And so if it matters to you, you can make the right kind of choice about which tool to use and which tool not to use. I think Playwright is great. I think Selenium is great. Today, we're going to learn how to use Playwright. Overall, in my experience, though, one of the reasons that I really do love Playwright, and I personally will probably use Playwright over Selenium in Python for the foreseeable future, is that I see Playwright as being Pythonic, right? Selenium WebDriver, the API you use, is very standard across all the languages. So it has that kind of universal feel, which is nice. But at times it can feel a little bit clunky in Python, especially when you have to do extra things like waiting, or you have to add on assertions and things. Whereas I feel like Playwright, even though it also has those multiple language bindings, the syntax and the way you use it, to me, feels more Pythonic than Selenium WebDriver. And as we know in the history of Python, Pythonic packages always win in the end. So, yeah. So how are we going to learn about Playwright today? Here's our outline. First, we're going to get started. That's what we're doing right now. We're talking about it. We're going to learn about how to set up projects. We're going to learn about, how browsers work and all these kinds of things. In this tutorial, we will literally build a test automation project from the ground up together. As soon as I'm done with this slide, we're going to dive into code, terminal, VS Code, all that kind of stuff. Then we'll take our first steps with Playwright. We'll formulate a test. We'll do some basic interactions. We'll talk about locators and elements and all those kinds of things. Then step 3, we're going to write some assertions for our test case. Then we're going to, once we finish a first pass of our test case with raw Playwright calls, we're going to refactor that into the page object model, which is much more reusable and scalable. Then we're going to learn about some nifty Playwright tricks. We're going to learn about things like parallelization, screenshots, video, all the goodness. And finally, bonus chapter, if we have time, number 6, we're going to learn how to test with APIs as well as UIs in Playwright, because we can handle both. What will you need for this tutorial? Not much. You probably already have it. First of all, of course, it goes without saying, you need your laptop, you need internet connection. You're going to need at least Python 3.7. I recommend the highest version possible right now, which is 3.10, but 3.7 plus should work. You're going to need a good Python editor. I'm going to be using Visual Studio Code. PyCharm's another excellent one. Whatever you like works. Also, for chapter 6, you will need a GitHub account. because we're going to be doing API and UI testing against GitHub repository. All of the example code that I'll be sharing today, as well as a full walkthrough of this tutorial, is available at this GitHub repository, github.com, Automation Panda, Playwright, Python tutorial. So you can go there. If you have to cut out early, you can follow the walkthrough and finish it on your own. If you've got friends or coworkers you want to share this with, send them the repo link. They can do this on their own. They just won't have me talking over their shoulders. So I see one question in the chat right now. Can Playwright be used with other test libraries, e.g. plain unit test or Zope test browser? Absolutely. There's no reason, or you don't have to use Playwright with PyTest. The reason I'm going to be using Playwright with PyTest today, first of all, I think PyTest is the best Python test framework out there. But secondly, Playwright provides a PyTest plugin, which makes it really, really easy to integrate. But yeah, you don't need to use PyTest with Playwright. In fact, there's two ways to look at Playwright. You can look at Playwright either as a test automation framework, or you can use it as simply a test automation tool, where it can be used not just to, or not, I shouldn't say test, it can be seen as a browser automation tool, where you don't necessarily need to use it for writing tests. You can use it to like visit web pages and scrape their contents and use it as a web crawler almost. You know, at its core, it's a browser automation tool. It just, the main use case for that is test automation. So good question. I should also say at any time, feel free to ask questions. Marcos here is going to be feeding them to me through chat. So as soon as I see them, I'll pause and I'll answer them. I want this to be interactive. I know virtual sucks sometimes. Personally, I love to give talks and especially tutorials in person because we see each other, and especially the tutorial, you can raise your hand and I'll walk over. But you know, we don't have that. So we've got to be on point with our virtual thing. And I think this virtual platform is pretty good. So let's make this as interactive as possible. If you have questions, you have comments, please raise them up. Marcos is my friend today. He's going to help me by, you know, dropping in the chat so I can actually see it. Also, I'll call out, we will be taking breaks during this tutorial. I know 3 hours is a long time. We're going to take breaks around the hour mark, so 11 and 12, 10-minute breaks each time. Just kind of step away, bio break, take a breather, give me a chance to rest. So that's what this tutorial today is going to look like. So, as said, let's start coding. Fire up your terminal, get Visual Studio Code open, and let's get to automation. So, for the majority of our tutorial, we will be automating one test case. Now, you might think, Andy, only one test case? That's kind of lame. How can you draw that out for 3 hours? Well, boy, let me tell you what. We're going to automate a test case for a DuckDuckGo search. DuckDuckGo is a search engine, just like Google or Yahoo. Why did I pick DuckDuckGo? Because no particular reason other than easy locators, which you'll see in a moment. But what we're going to do is we're going to first think before we code. We're going to step through a test case for searching a terminal DuckDuckGo manually. Then we're going to define it using given when then steps. And then we're going to implement it in Python code. And then we're going to improve it. It may seem simple, but there's a lot to unpack here. And I want to keep things simple because simple is better than complex. So follow along with me here. You can even try this on your own. In order to perform a search, what do we do? First thing we got to do is we got to load that page, duckduckgo.com. Then we want to look around and make sure everything is good. Okay, this looks right. Then what's the main interaction? We're going to search for a phrase. As the automation panel, you can probably guess what I'm going to search. We enter the phrase. We either click the button or hit enter. And then boom, what do we expect? We expect the result page to appear. Now, how do we know this result page is good? There's a few different things we can check on the result page. We can check the title of the page, Panda at DuckDuckGo. We can check that the search bar has our search term, Panda. And we can check that all of these links relate somehow to our search phrase. Here we got Giant Panda, Smithsonian Zoo, Britannica.com, Giant Panda, some news. Oh man, twin panda cubs born in Madrid. Oh, that's so cute. Little baby panda cubs. I got one back there. Look at him. His name is Otto. He's Otto, the automation panda. So this looks good, right? Panda bear. Woo. Oh, and then there's that panda song. Anyway, enough distraction. In and of itself, we have just performed a basic web UI end-to-end test. We loaded a web page. We performed an interaction. We waited for it to do its thing, and we verified the outcome. Even though that's a small test, it's a very powerful test, right? Because if DuckDuckGo can't perform a basic search, the whole app is done broke. Can you imagine working at DuckDuckGo and waking up one day and finding an outage where you can't even search for pandas? Oof, bad day for them. So it's a very valuable test. I would consider this like a smoke test or like the 80-20 rule, 80% of the value for 20% of the effort. Small test, big payoff. And also notice how we phrase that test. We followed an arrange, act, assert pattern. We arranged by loading the web page. We acted by performing a search, and then we asserted by checking things on the result page. Arrange, act, assert is the testing pattern of champions. It works for unit tests. It works for end-to-end tests. It keeps us focused on individual, independent behaviors. If you haven't heard of this pattern before, check out this article I've got from my blog, automationpanda.com. Arrange, act, assert. I did not come up with this. This is a industry thing, but it is something I strongly believe in. So, now that we know what test we are going to make, let's start automating that. So what we're going to do is we're going to create a new Python project for this particular test case. Well, in theory, it would be a test automation project that we could add more to. Where am I on my machine? Oopsie. Oh, shoot. Let's see here. Okay. So what we're going to do is we're going to make a directory, Playwright Python tutorial. Okay, and by the way, this is the part where y'all follow along on your machines. Have the Zoom window open on one, have your coding screen on another. So we're going to create a project directory called, let's just call it Playwright Python tutorial. Okay, and I'm going to enter that directory. Woohoo! And there's nothing inside. Yay, blank project. All right, inside this project, I'm going to create a virtual environment for all of our Python packages. If you're experienced with Python, you've probably learned all about, global versus local environments and all the different tools and stuff. If you're more new to Python or you haven't used virtual environments before, just a little quick intro. A virtual environment is where you save all of your package dependencies. You can have a global environment for everything on your machine, or you can make a local environment just for your project. It's a recommended practice to make local virtual environments per project, so that way a project's packages versions are all in line and protected, right? Because you may have one project that has one set of versions and dependencies and another project that might be older or newer or different somehow. And so you have those levels of protection. I don't use anything fancy. I'm going to use VNV, which is the built-in Python virtual environment module. So Python 3-m VNV. So this is going to invoke the virtual environment module, and I'm going to create that virtual environment in a folder called VNV. Why? Because I'm boring, and boring is good. Da-da-da-da. So now we've got that virtual environment in there. So now that we've created a virtual environment, I'm going to activate that virtual environment. I'm on Mac OS, so Unix, Linux kind of base thing. So to do that, I'm going to say source venv bin activate. For Windows, the command is a little bit different. On Windows, the command is just venv scripts activate.batch. So if you're on Windows, use this version of it. I'll Control C to keep that on the screen. But either way, once you do that, when you enter your virtual environment, you should see in parentheses the name of that virtual environment to the left of your prompt. So that's how you know you're active. Cool, cool. So now that we have a virtual environment, I need to get some dependencies in here, right? So first thing I need to do is pip3 install Playwright. Playwright is the name of the pip package that has Playwright for Python. Woo! Makes sense, right? So you're going to install this bad boy, and it's going to go all right. Oh, you're using a back version of pip. Okay, that's cool. I'm going to upgrade my pip here because I don't want this message to come out every single time. Paste. You don't need to. I'm just doing it. Okay. So another dependency I need to get is Pip Install Pi Test, because we will be using PyTest as our primary test framework. The runner, the structure, all that good stuff. If you're new to PyTest, imagine unit tests, but better, in my opinion. I like PyTest more. It has better features. I think PyTest is one of the best test frameworks in any language, and I use lots of different languages in my job. If you want to learn more about PyTest, pytest.org has excellent docs. Brian Ocken and Bruno Oliveira have excellent books. I've done a course on PyTest at Test Automation University. TAU, go there, take my course. Yay, awesome. Okay, so we've installed PyTest. And finally, I'm going to pip3 install PyTest Playwright, which is Playwright's PyTest plugin. That's a lot of P's and pulls. Playtest, oh my gosh, playtest. Playwright's PyTest plugin. Go. Cool, cool. So that's all we should need for now. If you want to see all the stuff that's in our environment, you can do a pip3 freeze. And wow, look at all this. We have packages. Cool, cool. So now that we've got the environment set up, there's one last thing we need to do for setting up Playwright, and we need to do a Playwright install. So what this will do is it will install the browser projects that Playwright will use. Playwright uses 3 browser projects. It uses Chromium, Firefox /Gecko, and WebKit. You might be thinking, Andy, well, I thought we were testing like browsers. What about Chrome and Edge? Why are you talking about things like Chromium? That's kind of weird. We'll talk about this a little more in a little bit, but Playwright doesn't actually test full browsers. It tests browser projects. That's part of the efficiency. That's part of the simpler setup. There's a bit of trade-off there because, you know, if you work at some big bank or government agency, they may have some sort of restrictions or legal reason or whatever, who knows, to say they must test on like full browser versions. But for most developers, it's going to be good enough to test on Chromium instead of Chrome. And so what this Playwright install command is doing is downloading the latest versions of, as you can see, Chromium, and now it's doing Firefox. It's putting it on your machine. So that way, when Playwright runs tests, it can go straight to those projects and hit those. You don't need to install browsers separately. You don't need to install any sort of executable. You don't need to update your path. Playwright does this magically for you. Also, for clarity, Chromium is the browser project used by Google Chrome, by Microsoft Edge, and by Opera. Firefox is used by Mozilla Firefox, and WebKit is used by Safari. So with these 3 browser projects, the browser projects themselves are like the open source projects of these browsers. They have the renderer, the engine, all that. With these 3 browser projects, you hit the bases of all the major browsers out there. So it's kind of like given to you, which is really nice. Cool. So our browser projects are installed. Now we can get to the coding aspect. So inside our project folder, we're going to create a directory called tests. In Python projects, tests is the de facto directory where your tests belong. It's where pytest goes to look for your tests. It's where I think unit test looks for them. It's conventional. You can change this. You can put your tests elsewhere, but stick to conventions so people know what's going on. And I'm going to create a file called testsearch.py. Cool. Awesome. So enough of this terminal stuff. Let's actually open Visual Studio Code. Now that we've got our folder there and everything. Woo! You can use PyCharm. You can use whatever Python editor you like. I like using Visual Studio Code. Yeah, fun times. So I'm going to open. Where did I put this thing? Open. Great. And let me increase the text size. Let me know if that's still a little bit too small. I can pump it up even more. Oh, shoot.
I think this is perfect, Andrew.
Okay, great. Thank you. Hold on one second. I spilled some tea on my keyboard. One moment. Nothing like bloopers on a live demo. One moment. I need to fix this real quick. My bad, people. I'm so sorry. Please bear with me. You know how tragic this can be if you ruin a $100 keyboard because you spilled liquid on it. Usually the live demo blooper is that the code doesn't run or something, not that you kill your machine. Lord, I apologize. I'm back. Oh, yes, I'm also team tea, not team coffee. Coffee gives me jitters and caffeine of that magnitude gives me headaches. So I'm tea. I love all kinds of teas. I love bubble tea. I love green tea. I love black tea. If it's tea, I'll drink it. The only tea I'm not so much a fan of the herbals because they're not actually tea. Okay. So what in the world? What happened? There we go. Sorry. Something's weird there. Okay. So, oh, that's why. Okay. So inside of our test search py module, we are going to add a test stub. Def test basic duck go search. I'm also going to be using type annotations just to help with the autocomplete in Visual Studio Code. You don't have to. It's something I've actually only started doing recently myself. So what I like to do is create test stubs before I actually write my test code. So I'm going to frame our test case using given when then steps in comments, and then we're going to flush out the code from there. So given the duck go home page is displayed, when the user searches for a phrase, and the search oh my gosh, so query is the phrase, and the search result links pertain to the phrase, and the search result title contains the phrase. Given when then arrange act assert. Given when then is the language of arrange act assert. This is how we frame individual independent behaviors in a test case. If you want to have multiple act assert, or when then, split the test. Why? Because when a test case fails, you want to know what one behavior failed. You don't want to have to dig through logs to figure out which of a chain of 10 behaviors failed. Always separate your test cases, short, sweet, to the point. Simple is better than complex. So here we have our test case stub. Ta-da! It has a clear name. It defines the behavior step by step. We thought before we coded, we did it manually. We turned that into a definition of a test case. One thing to keep in mind in your testing philosophy is that an automated test case should be nothing more than a direct implementation of test steps, right? There's a difference between test case and test code. Make your test case first. The automation should be a pure reflection of that. And what I consider to be the automation challenge is going from test case to test code as directly and simply as possible. So if we were to run this, let me open a terminal here. We can actually run this test now. It's not going to do anything. But just to make sure that everything is working, that we have the dependencies, that we have pytest. So anytime you want to run your tests, Python-m pytest, run the pytest module, and give it the path to your test cases, which are under the tests directory. And here we can see it discovered everything. It found the test module. We have a little green dot meaning passing. So it was a no op. It passed, doesn't do anything, but at least we know the whole mechanism, the whole framework, the basis, the foundation is there. So that's the start of our test automation project. One thing I should mention about test automation projects, there's a question you're going to have to answer when you first start writing tests. Do you put your tests in a new project all on its own, or do you put them in an existing project together with your product code? That depends. Typically, it's a better practice to put it together with your product code, right? Let's say you have a monorepo and you've got a web application in there. It would be a better practice to put your test cases in there because A, they're co-located, so it's one place for everything. B, less friction. If you want to write tests and develop it at the same workflow, you don't have to swap repositories and editors and all that. C, you've got the same version control, the same branching, which is really nice. But I understand that there are teams and organizations where that may not be so convenient. I know that, and especially bigger orgs, there may be completely separate test automation teams from a development team. I've been part of that. And so if there's like an enormous monorepo that takes like 10 minutes to check out and half an hour to build, it really bogs down the test team to have to work in the same repo as the developers. So in that case, it might be advantageous to have a separate repo where they can work more quickly. Or it may be the case where you don't have a monorepo, you have a whole bunch of repos that come together to create an application or even an ecosystem. And in that case, well, it doesn't make sense to put it anywhere because the whole thing is split out. You have microservices or you have multiple different things going on. In that case, it might make more sense just to have it as its own separate repo. So pros and cons of each approach, do what's best for you. Here today, because we're starting from nothing, I'm just creating a new project, a new test automation project entirely for these tests that we're writing. All right, so let's actually jump into Playwright stuff. Oops. Okay, so remember how I mentioned the browser thing was interesting in Playwright? I want to hammer this point down because if you understand this, you're going to understand how Playwright works, what you're actually calling when you make browser interactions, and ultimately why Playwright is going to be faster. So, as I said before, we've got those browser projects, Chromium, Firefox, and WebKit, and we're going to be sending interactions through debug protocols. But when we create a test, when we run tests, we want every single test to have its own, you could call browser session, so to speak, right? Because when, let's say we're doing that DuckDuckGo search test, we want to, open up that page, do the interactions, verify things without any interruptions. We don't want any other tests to come in that browser and use it. So every test is going to have its own little session, right? Historically, with Selenium WebDriver, what that meant was every test would have to launch a new browser instance, run through it, and then quit the browser instance at the end. So there's a lot of start a browser, stop a browser, start a browser, stop a browser. And every time you start a browser, it takes a few seconds. It could take up to like 5 seconds or even 10 seconds before you could start navigating the pages. Multiply that by a suite of 1,000 tests. Holy crap, that's a lot of time. That's why web tests are slow historically. Playwright has an optimization here because with Playwright, you have the browser instance, which is going to be that Chromium process or that WebKit process running on your machine. But every time you have a new test, it doesn't create a new browser instance. Rather, there's one browser instance, and Playwright creates a browser context that is a private, incognito-like session with that one browser instance. So again, you have one browser instance, but every test case takes a browser context. So that way you don't have to spend those couple seconds creating a browser instance and then a couple more seconds quitting it for every single test. Right there, you've saved a number of seconds that over 100 tests, 1,000 tests is going to be way more efficient. So here in this diagram, we can see how we would have one browser instance, and then we could have separate contexts. And contexts can even run in parallel. So if you're running 3 tests in parallel, you can still have only one browser instance, but 3 contexts where each one is still operating independently. It's awesome. Furthermore, within a browser context, you can have multiple pages. Oh, okay. What does that mean? Well, the page is the thing that you're actually interacting with, right? You load DuckDuckGo.com, it's on a tab or it's on a window. We call that a page. 99.0% of the tests I've ever written have only ever needed one page at a time. And I recommend, for the adage, simple is better than complex, you keep it that way. And that's how we're going to do it today. But if you wanted, you could have multiple pages within a browser context. So that's another level of, things going on. So in order to use this, with Playwright, if you were just using Playwright without the PyTest plugin, you'd have to do some calls here. You'd have to do something like this. I'm just going to copy and paste this here. From the Playwright sync API, you'd have to import sync Playwright. Then within that context, you'd have to launch a browser, Chromium, WebKit, Firefox, whatever. You'd have to create a new context from that browser. And then you'd have to create a new page from that context. And then finally, with the page, you'd be able to use interactions. This is a lot of boilerplate code. The PyTest plugin automatically handles this for us. So since we're using the PyTest plugin, we can make this import instead. From Playwright Sync API, import page. And then we can add to our test case the page fixture. The reason I'm importing page is to get that typing. That way we can have the autocomplete in Visual Studio Code. So the page fixture in that plugin that Playwright provides will do all of that, create your browser context, and get the page from the context for you automatically. This does use the synchronous API. So everything is, you don't need to have a whole bunch of await calls everywhere. In Python, I should back up. In Python with Playwright, you can either use sync or async. Sync, you're going to do the calls like we do today. Async, you're going to have to do a whole bunch of await and async methods and stuff. We don't need to do async. In fact, for simple better than complex test automation, right? You're doing one procedure. It doesn't really need to be async. You can just use the sync API. It's simpler. So that's what we're going to do today. So now that we have our page, we can start making calls to it. Given the DuckDuckGo homepage is displayed, how do we do that? That's a simple page dot oops, sorry. I was wrong. It's not so simple. My bad. Woo! Humbled. Page.goto. Also notice because I had the typing, the type checking, Visual Studio Code fills in the rest. Page goto. And in here, I'm going to put https://www.duckduckgo.com. Okay. And that is how we navigate to a web page. Pretty fantastic, right? Next, if we want, or actually, let's run that just to see it happen. I'm going to run the test again, but I'm going to add some more options. So by default, Playwright will run its tests headless, meaning you won't see anything. If you want to run headed like this, it'll actually pop up the window and render it and show you. Also, Playwright, like I said, is very fast. So I'm going to slow this down just so that we can see it. I'm going to slow it down by 1 second. So now when it runs, we should see Chromium pop up and we saw the web page load. So we know we're doing good so far. Cool, cool. So next we need to perform the search. And to perform a search, we need to find the element on the page and send things to it, right? So in order to do that, going back to my page, I need to say page locator. Locator is the thing that identifies an element. And in here, I need to give the selector. Now, I don't yet know what the selector is going to be. We need to go figure that out. So for right now, I'm going to leave this blank. But I know I need to get the search bar. So once I have that, what do I want to do? I want to send text to it. I want to type. The command to do that is fill. I'm going to enter in my search phrase. Once I fill in my search phrase, then what do I do? I need to click the search button so it can send it. Again, we're going to need a locator for the search button. I'll leave it blank for now. And what do I want to do? I want to click it. Ta-da! Okay, cool. So how do we go about finding what the search button should be and what the search input field should be? I find that the easiest way to find locators is to go to the page and to inspect the page. Use Chrome DevTools. So here, now that I'm behind the scenes, I've got the full DOM of the page. I've got the source of the page. I can turn things on and off. So what I do is in the inspect window, I go to this little arrow thingy and I click it. And now what happens is anytime I hover over an element, it highlights that element. And it will show it on the right in the page source. Super awesome. So let's get that search bar first. When I click it, what I find is this particular element, this input, ID, search form, input homepage. It's got a class, it's got a name, it's got a whole bunch of attributes. When we build locators, there are a couple ways we can do it. We can write a CSS selector, much like in your .css files. You can write an XPath, which is like the sledgehammer. Little clunky syntax, but it's the one that can guarantee to uniquely identify any element on the page. But if you want something a little more basic, look for an ID, right? Why? Because it's supposed to be the case that ID attribute values are unique for elements on the page. So here, this input has an ID. Oh, yes. Every time when I find an ID, I'm like, yes, this is amazing. My life is easy. There are a bunch of different types of locators you can use. If you go to the Playwright documentation, they'll go through everything of how to use it. Typically, my strategy is simple is better than complex. I look for a locator first, If I can't find a locator, then I look for an ID first. If I can't find an ID, I try to do a CSS selector. If I can't use a CSS selector, then I fall back on XPath. If there's a particular text value in Playwright, I'll use that kind of that kind of locator too. So here we've got an ID. So another thing I recommend you always do. I didn't want to search. One thing I always recommend you do is anytime you get an ID or anytime you get a selector of any kind, test it before you use it. Pop it into the Chrome DevTools here and make sure that it uniquely identifies the element you want. So here we're good. So back to the code. For an ID locator in Playwright, what I say is that ID equals, ta-da! You can also use a CSS selector if you wanted, but I like using the Playwright ID selector. Okay, so that took care of the input field. Let's also do the button. So this little hourglass thing, where's that? That one's here. Let's cancel this. And so again, we have an input with an ID. So I can just use that. Cool. So now if we run our test, it should not only load the web page, but it should navigate. It did it. It went very fast. I hope the Zoom screen capture caught it, but it loaded the page, it typed the thing, and it clicked the button. So cool. Now we've navigated successfully. That's awesome. One thing I will mention here is that Playwright has an alternate way you can call these. Instead of saying page locator fill, you could also say page fill and then give it the locator, comma, the text you want to fill. You might say that this is the better way because it's one call instead of two. But the Playwright team actually recommends that you use locators for everything instead of using page calls. And the reason why is because, as we'll see in a little bit when we refactor these into page objects, locators are more reusable, right, than just selector text. So keep that in mind. In a lot of existing code and a lot of existing examples, you might see this the page calls directly instead of locator calls. Ultimately, they're doing the same thing. But for better practice, I'm going to stick to using locators for everything. So just be mindful of that. It's not wrong. It's just a little older style, a little different. All right. So let's move on. Now that we've done our arranging and acting, it's time to do some asserting. There were three things that we wanted to check. We wanted to check that the search result query had our phrase. We wanted to check that the search result links pertain to the phrase. And we also wanted to check that the search result title contained our phrase. So let's do this first one here. Search result query is the phrase. If we were to perform that search manually again with inspection, this is that search result input field on the result page. And so if I look at where that is, input, type, text, tab, input, all this kind of, oh, this one has an ID as well. Nice. So now we know that we can get that element and we can say, you know, page locator, this thing. But the thing that we will need to do though, is not just get this element. And it's not we're going to interact with this element, but we need to get something from this element. We need to get its value. And not only do we need to get its value, but we need to perform an assertion on it. So we could use Python's assert command. But if we want to be a little bit better about it, we should use Playwright's assertions, those web-centric assertions. So to do that, I'm going to need to import the expect function from Playwright. And then we can form this, this assertion. So what we're going to say is I want to expect, and so this is performing that assertion call, that my element given by the page locator for a search form input so expect my page locator here, and then we're going to close that expect parentheses. So the expect call is there. And then we're going to add on a condition for that assertion. And notice, because I have the autocomplete with everything, expect, and then these are all the Playwright conditions. I'm expecting that thing, that element, to have the value panda. I want to get the value out of that input field. Boom. So we could have done something alternatively like this, just for comparison's sake. Assert panda equal page input value. We could have done it this way. This would be your more traditional way of doing it. This would be that pytest approved way of doing it. I suppose maybe that's not the right thing to say. This is how you would do it if you were just looking at pytest documents. But the reason why we'd want to do it this way instead of this way is because this call here, page input value, will wait for this element to appear and then get its value. But if, let's say, that element appears, but as part of the loading, it doesn't yet have the search phrase in there, there's a race condition here, and this condition might fail. 99% of the time, it's probably going to be fine. In fact, I've tested it with this version, and it is fine. But there's always that little eek, that little race condition there. Or it could be that maybe that field had a different value that needs to change to be the value that you want, because it takes time for things to load. With the Playwright expect call, what this does is it will wait not only for this element to appear, but it will actively keep checking until the value given by this element is the value you expect. So this is a much safer, much more robust kind of assertion. That's why we would use this web first assertion versus a more traditional assertion. Also, I should pause and say here, any of these locator calls that we see, like locator fill, locator click, expecting a locator, they do have automatic waiting that Playwright will wait for those elements to appear on the page before trying the interaction. In Selenium WebDriver, there is no automatic waiting. Basically, if you were to make this call and this particular search input isn't yet on the page, then Selenium WebDriver is going to explode, throw an exception, and say, I'm done. Playwright, on the other hand, if it finds that this is not yet visible on the page, it'll wait for a timeout. Be like, okay, it's not ready yet. We'll keep waiting. Check again. Oh, not ready. Oh, it's there. Okay, good. Right. That's how Playwright eliminates a lot of flakiness. I didn't need to make an explicit waiting call. Did it for me. I believe the default wait in Playwright is 5 seconds. But you can adjust that. You can tweak that if you want. So let's run this test one more time just to make sure that our assertion is good. And what we should see is the test should pass. Boom, 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 boom. Nice. And we're passed, so we know our assertion is good. Cool, cool. So this was the easy assertion. The next one is going to be much more intense. So we're at the top of the hour, 11 o'clock. Let's take a 10-minute break. And let's be back here Eastern time, 11:10. Does that sound good? Meanwhile, feel free to drop any questions in the chat. I can answer them once we come back. And at 11:10 Eastern time, we shall continue on with our asserting.
We're having a question on Slido, and
Okay.
Actually, let me paste
Sure.
here. That has been some time ago by Isabel. So, Isabel, I hope you're still around.
Okay, so here's a question. I got the following error from Playwright install. What should I do next? Error, Playwright does not support WebKit on Mac 10.13. That's odd. What version is my Mac? What am I on? Version 12.1. Okay. So I don't know. I mean, I would guess that, yeah, maybe your Mac is just a bit too old that it can't handle WebKit. I would ask, could it at least do Chromium and Firefox so that you could still run browsers? Or did the whole command just not install the others whatsoever? As long as you can run at least one of them, like Chromium or Firefox, you can at least move forward. If it's just that your Mac is too old, I'm sorry.
I have a question as well, Andrew. You think it's a good time now to ask?
Yeah, go for it. Let's do it.
So the idea is that if you want to find the selectors, but you want to do it through Playwright, so somehow more interactively. Sure, you have another browser where you're trying to find the selectors, but how about can you do it? How would you do it from within Playwright to get some hints that you're actually getting the correct locator?
Oh man, like purely from within Playwright, I don't know, because like the way I see it is like you have to have knowledge of the page in order to write selectors to get elements. And so like from the context of like writing a Playwright test, the test doesn't really know what the page is. You have to tell it what the page is. So that's why I showed Chrome DevTools and I opened up and I went into the page. You could also like go into the source code of the website or the web app and try to find it that way. I use DevTools because I think that's just the easiest. I don't think there's a way that you can like explore purely from within Playwright. I mean, another thing. Go ahead.
Yeah. Can you use PDB? Probably.
You can use PDB to debug to step through.
It's a common practice.
I personally would not use PDB to step through these tests. I would probably use like PyCharm's debugger or Visual Studio Code's debugger to step through more visually, more manually. But yeah, I mean, you could. I know about PDB. I mean, you could set breakpoints and you could kind of step through each way and see. Debugging your test case is actually very, very helpful when you have a problem with the locator. Because like frequently what I will do in that case is, let's say, for example, this locator here is just not working. Like it's not clicking for something. I'll set like a breakpoint here, and then I will run my test in headed mode. And so as soon as it hits here, it stops. My browser window is open. Then I will go into the browser and see like, okay, what is the page actually doing at this moment in time? I'll open up debug tools, try to figure it out. And usually I can resolve any sort of locator issues I hit with that sort of debugging. You could do the same thing with PDB, just same workflow, different tool.
Perfect.
Great question though. Awesome. Do we have any other questions, Marcos, or shall we continue with the coding?
Yes, please continue.
All righty. So, we did our first assertion, which was check your input field. Cool, cool. The next one is to make sure that all of the result links on the page somehow pertain to Panda. Now, this one is a little more, how to say, I don't want to say ambiguous, but there are, or the thing we're trying to check is more amorphous. It's like, we want to make sure, qualitatively that we're getting good links, right? That if I search for panda, I'm not getting results for bananas, right? So how do we make sure that all the result links are actually linking to something with the topic? Since this is just like a basic kind of test, we're not looking for like super duper accuracy or anything, right? We just want to get a general sense. And since we're also using a plain old search term for this, we can keep things simple for ourselves. So one thing we can do is we can get the titles of all of these links, right? Like here, the title would be Panda Express. The title here would be Giant Panda, National Geographic. We can scrape these titles and parse them and see if the word panda appears in those texts. And if there's any, if there are any links that don't have panda, then maybe we could fail and say, hey, we have a link that doesn't belong here. So if we inspect what these links look like, we can see here that the hyperlink itself is an A tag. They've got a class called result A, and they are under an H2 element that has the class result title. So if we wanted to come up with a CSS selector for this, not just like an ID, because we don't have direct IDs, we're trying to get a list of things. I could say, okay, start with the element that has the class result __ title. And that would give me all of the H2 elements. And we can see there's 10 of them for 10 results. But if I want to specifically then get the hyperlink element, I can say a.result __ a. And so that will uniquely identify the 10 hyperlinks for those titles. And we want to get the hyperlink because that's what actually has the text inside. The H2 element doesn't have the text inside. The H2 element has the hyperlink. We want to get the hyperlink has the text inside. So we can scrape that. Now, we could use other kinds of selectors, right? I mean, we could hinge off of things like some test data ID, or maybe some text searching, whatever. We could do things like that, but I'm going about it this way just to be like, hey, because we want to make sure, like we could search for any element on the page that contains the text panda, but that would get not only the hyperlink text, that would get like the article things, it might even get some URLs. Not quite what we want. I want to focus on the hyperlink titles. So more than one way to handle this. We're going to do it this way. So I've got my selector here. So first thing we want to do is we want to make sure that these elements load, right? And in this case, we're not just dealing with one element, we're dealing with multiple elements, right? Because it can take a page a little bit of time, get the first one, get the second one, get the third one. And so here, since we're dealing with a list of elements and not just one element, things become a little bit tricky, right? Because it's easy to say, wait for the appearance of something. But, if there's multiple things that need to appear, what we really want to say is wait for a certain number of them to appear, right? So in this case, I need to do some explicit waiting. I need to tell Playwright, wait for a certain number of things to appear on the page. And the way we do that, again, is using our page locator. So we can say page locator And the locator that we're going to use is a CSS selector. We don't need to say like CSS equals or anything. We can just pop in the CSS selector here. So this will identify a locator to find these elements. But we want to say, I want to wait for a certain number to appear on the page. And for that, we're going to add an nth element selector method. And let's say we want the first 5 elements to appear on the page. You know, we could say 10, but certain search phrases that I've tested don't always give 10 elements on a result page for DuckDuckGo. Sometimes they only give 5, sometimes 8. So let's be safe. We don't need that all of them. We can just say, give me enough to be good. Remember, this is a basic test, kind of like a smoke test. We're not going for perfection. We're not going for 100% accuracy. We're going for basic workingness of search. So let's make sure that the first 5 appear. Nth element selecting is 0 based. So 0 is the first one, 1 is the second one. So if I want the first 5, I got to say nth 4. And then I'm going to say, okay, get me the locator, or get me the element given by this locator, give me the 4th or the 5th one, and then wait for it. Adding on this wait for call will wait for its appearance. So here, this is an explicit wait. I know I said earlier Playwright does implicit waiting, but since we are waiting for a certain number of things to appear on the page, we have to do an explicit wait. So once those elements have appeared on the page, what I then want to do is I want to scrape their text, right? I want to get those. I don't want the elements themselves. I don't want their hyper references. I want the text of their titles. Now you might be thinking, okay, so that means I have to like get a list of elements and loop over every single one and get the text and map that list to get the text values right. That's what you'd have to do with Selenium. Playwright has a convenient call for this. We can do this. We can say list of titles equals page.locator. And actually, it's going to be the exact same list of elements, so I can use the same locator. Dot all text contents. What this does, it says, oh, you have a list of elements? Make a list of all the text contents of each one and slap it together in a Python list. Beautiful. It does it for us. That's so great. Now, again, the reason why we needed to do this explicit wait is because if we were just to call this, if the page hadn't finished loading all those links, let's say the list of links was empty, then this call would pass and it would just yield an empty list, right? Because Playwright doesn't know how many are going to, or it doesn't know the ultimate size of the list to wait for. So it's just going to say, okay, well, I'm just going to take whatever's there. So you have to explicitly say, wait for at least 5 of them to get there, then grab the list. So once we have the list of titles, what we need to do is we need to make sure that Panda appears in them. And I would even say, excuse me, let's make this a weak kind of assertion, because if I were to use different search phrases like penguins or parakeets or something, given the nature that this is live data, these are live results, phrases might not appear in every single link. There may be something that still pertains to your search phrase, but doesn't have the exact search phrasing in there. And so what I would say is, let me just make sure that it's in some of them, right? So to do that, let's first get the list of matching phrases. And then what we can do is we can assert that the size of that list is non-zero, or the size of it is greater than some number. So I'm going to say matches equals, I'm going to use a list comprehension here. Sorry about that. I'm going to say the title for title in titles if Panda in the lowercase version of that title. So what this will do is it will take our list of titles. It'll iterate over each one using a variable called t, and it will filter through if the lowercase version of our title contains the string panda. So that means now this matches list is only going to have titles that contain the word panda. And we can make an assertion on this list, and this will have to be a typical or a traditional PyTest assertion, no special Playwright thing here. I want to make sure that I have at least one of those titles matching, right? If I have one out of my list of results, I'll consider that good enough that the search was a success. If we wanted to be stronger in our assertion to say that, all of them are matching, we could do something like this. We could say like assert length of matches equals the length of titles. That would be a very strong assertion to say every single title needs to have our search phrase. But I'm going to leave it weak just to help test reliability. Because like I said, if we were to shove different search phrases in here, or if we were to run this on different days and the results change, who knows what could come through. Ideally, for test automation, you want to have as much control over your data as possible so that you can make the strongest assertions possible. Right now, we don't have that luxury, so we're going weak. So let's give this a run and make sure it works. Load the page, boom, boom. So great, it passed. Both of our assertions are passing. Let's do the final one, where we're going to check the title. Now, what's unique about this one is that the title is not an element on the page. The title is an attribute of the page. So for the title, we don't need to make a locator call. What we're going to do is we're going to get the title value and make sure it contains the search phrase in it, panda. Now, I could make a traditional PyTest assertion like this. Assert panda in page.title. But again, this has the issue, like we said before, with the other assertion where this will just get the title and whatever it is. It won't actively wait until the title reloads to have the right thing we expect. So we're going to use, again, Playwright's expect. So we're going to say expect page dot to have title panda at DuckDuckGo. And boom, that will take care of it for us. We can remove that pass call. Pass is basically Python's no op. So we can get rid of that. And now we have a completed test. You can see the fullness of it here from the one import statement we have, given, when, then. Oops. So let's run it one more time just to make sure everything's hunky-dory. And boom, we're passing. Very cool. So one thing I want to call out is notice how concise this code is, right? What I love about Playwright is that its syntax is very readable, very concise, very Pythonic, right? It's, you want to load a page, go to the page, locator fill, locator click, expect your locator to have a value, expect your page to have a title. Very fluent-like syntax, as if you're reading plain language. So it's very nice. So this is a fully functioning, working Playwright test. And we could stop here and be done and say, we're good. But this uses what I would call raw calls, right? Inside your test case, you're making these calls to the page directly. You're making these calls to locators directly. You have a whole bunch of hard-coded stuff like page URLs and selectors and search phrases, all that kind of stuff. This is cool if you're doing like a hacky kind of web scrape one-time thing. But if you are trying to build a high-scale test automation project, this ain't going to scale, folks. And I can tell you, I mean, I've worked on some stuff that's, hundreds to thousands of end-to-end tests. And so like projects where like the test automation code is just right. And it's not the kind of case where, well, you really should have written unit and integration test. No. These were enormous enterprise scale applications where we had tens of thousands of unit tests and we had thousands of end-to-end tests. So even if you apply good testing strategy, you can still end up with large suites. And so with test automation code, what you find is that it is very susceptible to code duplication, very susceptible to code duplication. And we even see it right here in this test case. Look at these two lines. We basically duplicated locator code here, right? The selector is the same, right? Ooh, those are things that we want to kind of avoid, right? We want to make things more reusable. We want to make things more readable so that we can scale better. And so if you are building a serious test automation suite, one thing I would recommend is to look at design patterns that help you better reuse code. So what we're going to do next is we're going to refactor this test case using something called the page object model. Page object model has been around almost as long as Selenium. It is to this day the de facto design pattern, if you can call it that, for modeling web pages for test automation. Now, if you know me in other spaces, I actually prefer something called the Screenplay Pattern, but that's a whole nother talk, whole nother tutorial. We're going to keep things simple, and today we're going to use page object model for refactoring. Page objects are still good. I think Screenplay is better, but let's go from all right to good before we can go to awesome. So in page object model, your page objects are basically classes that represent pages that have the locators and have interaction methods. In our test, we essentially have two pages. We have a search page that we're loading and we're, typing in a search phrase and clicking enter. And then there's a result page where we're not necessarily interacting with the result page, we're just kind of getting stuff from it. Let's start with our search page. So to create page objects, what we want to do, actually, we're going to put them in a different Python module. And not only a different Python module, but an entirely different package, an entirely different folder. All of our tests went under the tests directory. I'm going to create a new folder called pages at the top level. Note, this is not tests/pages. This is from project root pages on the same hierarchical level as tests. And not only that, but I'm going to make this a Python module by adding the dunder init.py module. And we're going to leave that blank. Now you may be wondering, Andy, why in the world are you creating a separate Python package outside of the tests directory? Because I want this to be reusable as possible, right? What we're going to do is we're going to import these modules into our test code. And the way PyTest has things structured, you can't really, or you should not turn your tests folder into a module. You're supposed to leave that as just a folder. Or sorry, you're not supposed to turn tests into a package. You're supposed to leave that as a folder. And so then your import statements and trying to import test modules into, trying to import modules into test modules gets a little tricky. So the way we're going to do this to keep it simple, not have to do any special PyTest config, we're just going to make a new package called pages and pop it here. Gosh, lots of P sounds today. Inside of here, I'm going to create a module called search.py. Boom. And this is where we're going to put our search page class. I'm going to call it class duck go search page. This is being explicit. We probably could have just called it search page, but if we were testing a large application or we're testing multiple different kinds of pages, giving that little bit of description kind of gives clarity to it. So we'll roll with it for now. Inside of here, I am going to create a class variable called URL, and I'm going to give it https://duck oops, sorry, www.duckduckgo.com. Now, typically, you don't want to hard code URLs, or I should say base URLs inside of your page objects. What you really want to do is you want to read them in from an external source, like a config file or a command line argument or something, and then pass that through into your tests. But for convenience today, we're just going to pop this in here as, you know, as a target URL. This is not the best practice, but for the sake of this tutorial, this is what we're going to do. Then inside of here, we're going to create the init method to essentially be constructor-like for this page. Now, what I need to do is I want to pass in Playwright's page so I can perform interactions. That means I'll need to import, I'll need to import the page class from the Playwright API. So I can do my type checking, declare page here as something I'm passing in, and then store that self.page equals page. So now we have all the wonderful type help. In addition to the page that we're passing in, we also want to create our locator objects, right? Now, here's where it's going to become important to recognize what locators are and how they function. So we have a search button. I want to say page.locator. And essentially, I'm just going to copy what that locator was. Make my life easy. Page locator. Next that part of it. And then we also have a search input. Oh, I got these backwards, didn't I? Whoopsie. One moment. Live coding is always fun, right? The button is the button. The input is here. So here, what I've done is I've created locator objects and I've stored them here. Locator is separate from an element. The element is the actual thing on the page. The locator is a pointer to the element on the page. So here I can construct locators in this page object constructor, even though the page isn't loaded and the elements don't ethereally exist yet, right? What I am creating is I'm creating a locator object to say, hey, I have a pointer to where that object is. And so I'm going to set them here. Another thing you could do, if you want to be like super abstract, you could take these selectors and make them class variables or constants or something. I'm not going to do that. I'm just going to pop them here. I think this is good enough because what I really care about is the locator, not the selector. I see a question from Jorgen. Could you tell us the third way to do tests Andy mentioned, the one that is even better than page object models? Let's save that for the end of the talk because I have opinions there. If you want to look at it proactively, it's called the Screenplay Pattern. The Screenplay Pattern. I'm not going to use Screenplay today because that would take more time. There's a bit of boilerplate, and there's also not a good Python implementation yet. But if you want to look it up, you can look up the Boa Constrictor project. That's my .NET implementation of Screenplay. I think it beats the pants off of page objects. So, hope that helps, Jorgen. Knock your socks off with that one. All right, so we have our page object. We have a constructor. We have the locators constructed. So now we can make the interaction methods. So first interaction method is to load a page. So I'm going to say def. I'm going to call it load. Not going to return anything. And in here, what I'm going to say is self page go to, just like we saw before, self URL. Ta-da! Easy peasy. Should look familiar. Other thing I want to do is I want to search. And not only search, but I want to search for any given phrase. So I'm going to call this method search. Self. I'm going to pass in a phrase. String. This ain't going to return anything either. So now instead of calling the page directly or constructing fresh locators, I'm going to use the locators I already have. Self search inputs dot fill phrase. Beautiful. Self search button dot click. Already we can see how this code here, this structuring makes things even more concise. It takes more lines of code, but the lines themselves are much more readable, much more intuitive, because it makes much more sense to say something like self search button click than to say page locator ID equals search button home dot click. Right? You can figure out what this means, right? But this doesn't tell you, oh, like smack in the face, like search button click, like this does. Much, much nicer. Now that we have our page object for search, let's save it. And I can come over here and we can import the page object. We can say from, gosh, I can't type, pages.search import go search page. And at the top of my test function, I can say search page equals go search page, pop in the playwright page so it can perform the interactions. And then I can start refactoring my calls here. So instead of saying a raw page.goto, I can say search page.load. And instead of having 2 lines of call for a search here, I can say search page.search panda. So now these interactions are even more readable. Like I said before with the test automation challenge, trying to go from test case to test code as directly as possible. My test step, given the DuckDuckGo homepage is displayed, search page load. That's direct. This is easy to follow, easy to trace, easy to add. And we could use these methods in other tests if we wanted, because if we had to write more DuckDuckGo search tests, how many times do you have to load the page? How many times do you have to perform a search? Save yourself the code. So let's run this test again. Functionally, nothing should be different. It should pass. But we've just refactored to make the code more readable, more reusable, more understandable. Sure enough, boom, everything passed. Cool. Nice. So let's do this as well for the result page. So we have a search page. Let's make a result page. Result.py. And so in here, I'm just going to start by importing some of the things we need. For typing, we're going to need the page, as well as we're going to need list from typing. So again, I'm going to have my class, definition. I'm going to call it DuckDuckGo result page. And I'm going to have the same type of constructor where I have, pass on the page, store it. Now here, there were 2 locators I needed. I needed a locator to get me the result links, that list of result links. And there's the locator I needed for the search input at the top. As you recall, title is an attribute of the page, doesn't need a locator. Now, as we recall from our test case, there were lots of assertions we were making, right? But one thing we want to do is we want to have a separation of concerns. I believe strongly that page objects should model pages. They should not perform any assertions. Why? Because think about it. If you're trying to scrape something for a page to check it, then there are multiple things you could be checking for, right? You could be checking that something appears or that something doesn't appear. You could be checking that it contains a phrase or that explicitly does not contain a phrase. If you start trying to embed assertions into your page object calls, then you're going to need to duplicate a lot of your page object methods. Very bad. So instead, I keep assertion code exclusively in my test functions because that is a test concern, not an interaction concern. So we're not actually going to add any sort of methods for these. We will use the locators, but we won't port over any of the assertion logic. And that way we can continue to use the expect calls with those smart web first assertions. But we can move over a lot of this logic, right? Because there's a lot of munging going on that a test shouldn't have to worry about. Should be more of like, you know, a question you're asking of the page. So let's code up some of that here. So first thing I want to do is I want to get the list of result titles because I need that list of strings first, because that's one concern. So I can say result link titles as a method, and this is going to return something. Unlike the interactions that just did stuff, this is a question that's returning something. I want to return a list of strings. Excuse me. And so I'm going to say self my result links, use that locator. Again, do my wait for the first 5. Should look familiar. And then I'm going to return self result links all text contents. That same method before. So now I have a way to just easily get all the result link titles. Right? All the Gorpy stuff hidden behind me, I can just call this from the page object. So then what I want to do is I want to refine that. I want to say result link titles contain phrase. I want to have a condition that checks, hey, do my result link titles contain a particular phrase? And this will return a Boolean true false. And then we can assert either way on that true false. So I need myself. I need the phrase we're going to pass in as a string. And I'm also going to set a minimum threshold. And I'm going to default that to 1. And this is going to return a Boolean value. So what do I need to do? First, I need to get the titles equals self.result link titles. Get that list in here. Then I'm going to do the filtering. Matches equals T for T in titles if phrase dot lower in T dot lower. Should look familiar as well. We're just using a generic phrase now instead of an explicit one. Return length of matches greater than or equal to our minimum threshold. So that way we can customize it. One nice thing about page objects is instead of hard coding things like the phrase and your thresholds, you can do these, you know, more generic kinds of things so they're more reusable. And so this will return a condition or a Boolean indicating whether or not your link titles contain your phrase according to your threshold. So going back to our test case, again, now we can import the other one from pages.result, import DuckDuckGo result page. I can result page equal DuckDuckGo result page, pop that in there. And now I can replace some of these things here. So the assertion call, the expect call for our first assertion is going to remain. But what I'm going to do here is this locator can be fetched from the result page. Page.search input, right? That way I can reuse that locator. This call can entirely be replaced. Get rid of all this mumbo jumbo. What I want to do is I want to assert not that condition. I want to say assert result page result link titles contains phrase and pop in the phrase panda. And then finally, this one is not tied to the result page at all. It's just tied to the page, so this doesn't need to change. And just like that, I have simplified my test using page objects. I can reuse those page objects in other tests, so I don't need to duplicate locators or searching or any of those kinds of things. Run our test one more time, make sure it works. Success, Panda. Sweet. Awesome. So page objects, good stuff. We've done the refactoring of the code, which is nice, but we can actually take this a little bit further with pytest. If you notice here, one of the things we said was, hey, pardon me, using page objects is going to make things much more reusable in other test cases, right? So I can use the search page and result page in other tests. Unfortunately, if we were to construct our page objects here, that means every single test that uses these page objects needs to construct these page objects in the test. That itself becomes duplicative. It's better than the duplication we saw of this kind of code, but it's still a measure of code duplication that we can eliminate. PyTest has something awesome called fixtures. Fixtures are functions that do setup and cleanup and then inject their results directly into test cases in a very reusable way. What we can do is we can create fixtures that create these page objects and then just receive them by declaring them as fixtures, as arguments in our test functions. So let's do that. This is kind of like an advanced PyTest thing, but it's quite useful, and it's not a particularly difficult thing to do or to understand. So what we want to do, anytime we want to make custom fixtures, we can either add them directly in our module, or if we want to share fixtures across multiple test modules, we put them in a file called conftest.py. So I'm going to do that. Inside your test directory, make a file called conftest.py. This name is dictated by PyTest. So in here, what we're going to do is we're going to import a whole bunch of stuff. We're going to import PyTest. We're going to import our page objects, and we're also going to import the page class from Playwright. And I'm going to create a PyTest fixture. PyTest fixture is just a function. Let's create a fixture called result page. This fixture is going to take in the page fixture, and it's going to return DuckDuckGo result page. And all we're going to do is say return DuckDuckGo result page. We're going to construct that object. Now, in our test case, we can call the result page fixture and have this result page object constructed for us automatically. We can do the same thing for search page. Boom. Nice. So now we can go back to our test, and instead of putting these things here, we can declare them here. Boom. Now we don't need to redundantly construct them every time. We just need to declare them as fixtures. So we still need to have the page fixture here because we have that one condition on the page. But search page, result page, boom, there you go. We don't need to import anything explicitly from conftest.py. PyTest takes care of all that for us. And so now we have a complete test together with custom fixtures. As always, run it one more time. Should pass without a hitch. Cool. Very, very good. So before we take a break, let's cover a few little cool PyTest tricks, or Playwright tricks with PyTest. So far with this test case, when we've been running it, we have run it against Chromium, right? That's the browser window that's popped up. But as you'll recall, when we installed our browsers, we installed Firefox and WebKit as well. And Playwright took care of that for us. We can do cross-browser testing with Playwright locally here. What we can do is, instead of just running, we can add an option to this command to explicitly specify the browser. So I could say browser Chromium, and it will explicitly hit Chromium. Or if I wanted to hit Firefox, I could say, hey, test Firefox instead. So now when I do this, oops, it pops up Firefox and does the exact same test. It still passes. I could also do WebKit. And you could probably, it might be a little hard to tell, but the window looks a little different. That kind of verifies that we are testing different browsers. What's really, really nice about this is that with these commands, you are passing the browser choice into the test. This is good practice because in theory, your web applications should work the same in any supported browser. And therefore, your tests against those web apps should also be able to point and shoot at any given browser and run successfully. You don't want to hard code a browser choice into your test case. Like we saw before when I was typing out, when you had to get a browser or browser context in a page, explicitly, we typed out like Playwright Chromium and explicitly put that in the code. That's typically not something we want to do, because if you hard code the browser choice into your tests, that means if you ever want to run a different browser, you have to go into the code and change it, right? Browser choice should be an input to automation. And so what's really nice with Playwright's PyTest plugin is that you have this command line option to choose the browser you want. That's really, really awesome. That's good practice. And the fact that they even make it a command line option is just like, oh, it's fantastic. Not only that, but you could run multiple browsers at the same time. So I could say browser Chromium, browser Firefox, browser WebKit, all at the same time. I'm going to add the verbose so we can see what's happening. I'm not going to run headed. I'm going to run this one headless because I don't want all the browser windows popping up. But take a look to see what happens. So you can see in headless mode, first of all, they're flying even faster than when we had them up. But you can see that one test case ran 3 times. Basic DuckDuckGo for Chromium, for Firefox, and for WebKit. They all passed. They ran serially one at a time, but in one test ran 3 times. So you can do that as you like. Now, another thing to keep in mind is that, like I said before, these are not full browsers or stock browsers. These are browser projects, right? Chromium is different from Chrome. Now, the rendering in the engine is all the same, so it's debatable whether there's truly a difference in testing Google Chrome versus Chromium for the sake of web test automation. In my opinion, I think it's close enough that I'm not worried about that risk. But there are places and teams and companies and orgs and whatnot that have very strict rules for compliance, for legality, for, I don't know, maybe there's an executive or a VP who just is very, very strict on certain things. So some teams may have to test Google Chrome or Microsoft Edge instead of Chromium. Playwright lets you do that as well. You can do it using what's called a browser channel. So in this case, what you can do when you run your tests, instead of saying browser, like this, browser Chromium, you say browser channel, and you can choose Chrome or Microsoft Edge. I'm going to do Chrome here. Now, the caveats with this are that you must have that browser installed on your machine. If you didn't have MS Edge, it's not going to work. And this only works for Chrome and Edge. They don't have browser channel support for Firefox or for Safari or any other browser. So there is that limitation, but it will still work. And so here it's running the test, ran it against Chrome. Boom, there you go. It passed. I found that browser channels tend to be a bit slower. This time it seemed to be just as fast. So I don't know what's going on with that. You can also do mobile emulation. You can't test web apps on mobile browsers, but you can emulate mobile browsers. So you can say, hey, I want to test the device, iPad mini, right? It'll pick a default browser, I think, on this one because it's what's it called? It's an iOS device. I believe it'll default to Safari, or sorry, WebKit, default to WebKit. And you can run that. You could also specify explicitly if you wanted a particular browser. And particular device. So that'll test that. In fact, let me do that one headed and slow-mo so we can see it more readily. You can see the mobile emulation actually uses, the proper viewport size for that kind of device. So it's the reason you would do that is to test your responsiveness of your web app. So that's pretty cool. Okay, so it is 12 o'clock on the dot. So let's pause here and take another 10-minute break. And we'll come back at 12:10 Eastern time. And when we come back, what we'll do is we'll finish covering some more little cool Playwright tricks. And we'll also start making headway into our bonus chapter on API testing. So thank you, everyone. If you have questions, feel free to hit us up. Go take your break and see you back in 10 minutes. Okay, we're at 12:10. We have 35 minutes left. We will probably not get through all of the final chapter, but that's okay. That's a bonus chapter anyway. So the plan here for the rest of the day, we're going to finish up with some cool little Playwright tricks. I showed you how to do different browsers, cross-browser testing. We will get into a little bit of API testing, and then if we have any time, I can just open the floor for questions and other kinds of stuff. In fact, here already, I see in the chat, we've got another question come in. Andy, how much took your biggest test suite to run? I guess how much time did it take your biggest test suite to run? It's a great question. So I actually have a whole article on this. How Q use BDD spec flow. Right now, I'm a developer advocate at AppleTools, where I help people learn about visual testing. I do events like this where I teach general testing practices and tools and stuff, and also run Test Automation University. But in my previous life, I was the lead software engineer in test for Precision Lender, which is now owned by a company called Q2. At Precision Lender, I was the first software engineer in test. I built up the project and the practice from the ground up. And we built a high-scale test automation project called BOA, B-O-A, like the snake. The reason we called it BOA was because we did it in C#, even though I had thought maybe we could do it in Python. So if I can't have a Python, I'll have a different kind of snake. A little tongue-in-cheek there. But you can read all about that project here on my blog at automationpanda.com. The title is How Q2 Uses BDD with SpecFlow for Testing Precision Lender. Even though it's not a Python project, the practices, the things we did regarding testing all apply. When I left in November of 2021, when I left that team to join AppleTools, at that time we had over 1,800 unique end-to-end test cases. They averaged about 20 to 60 seconds long each, logging into the PL Lab, doing various individual behaviors. And we would run them anywhere from 50 to 100 times in parallel 50 to 100. That was the scale of execution that we had. When we run it at that scale, the entire suite took 15, 20 minutes in our continuous integration environment to run. Continuously after every single deployment internally, every single code change, we would run a set of 1,000 of them against one particular bank configuration. That would take about 10 to 15 minutes. And then overnight, we would run the entire suite against different banking configurations. So like that, because there were multiple runs of it through, it would take, you know, upwards of an hour, 45 minutes to an hour to run everything. But it was very reliable too. It's pretty cool stuff. So read the article, find out more about how we did it. Good question. Okay, so where are we now? Back to Playwright land. So we showed how to do cross-browser testing. I want to show you also how to capture some other kinds of things here. So one really nifty thing is to capture screenshots of tests. So if a test runs and it fails, right? Okay, it failed. How do we know what failed? It's really helpful to have a visual to see, aha, this is what's wrong. So you can add screenshots to any test like this. Use the screenshot option. If you want to capture screenshots after every single test, whether it passes or fails, use on. If you only want to capture on failure, use only on failure. This is what I recommend. Typically, when a test passes, you don't need to use up extra storage space on your machine to store those screenshots. What you really care about is when they fail. However, since our test is passing and I want to show you this feature, let's run it with it on. So boom, you'll notice that in your folder, Playwright will create a new directory called test results. And in here, you will see for the folder after the name of your test case, you'll have a screenshot here of when the test ended. So that's what it looks like, right? That looks about right. Whoa, stop. In addition to screenshots, you can also capture full video. That's right, you can capture full video recordings. This is something that Selenium doesn't do out of the box. It's kind of a pain in the butt. I find video is even more helpful than screenshots. If you want video, again, it's just the video option. If you want to capture every video, you can say on. If you want only videos of failed tests, retain on failure. Why it's retain on failure, whereas screenshots are only on failure, I don't know. Somebody go open an issue on GitHub against Playwright Python. Whatever. Okay, it's cool. I'm going to do it on just to show you what it looks like. It uses like an open source video format. The thing that is kind of wonky about this, it'll put it in a subdirectory after your test name and all, but the video itself is kind of, let's see, you can see it's this horribly ugly hash. I can't open it in the editor. That's right. If you want to open this, another little hokey pokey thing you got to do. Oh, you have to open this in a web browser. So I'm going to say reveal in Finder and open with Google Chrome. And so here, wow, it's like super fast. But you can view the video. This might be where you might want a slow-mo or something to help you trace through. But it runs the whole test and it's all there. So it's pretty cool stuff. Again, I recommend only capturing that on failure. Finally, another cool Playwright trick that's not necessarily a Playwright trick, this is more of a PyTest trick, is running your tests in parallel. Now, as Jorgen had asked before, like, Andy, how long does it take to run your tests? And I said, okay, we had it so where we could run 1,000 tests 50 times in parallel, and it would take about 12 to 15 minutes. If they weren't running in 50 times parallel, it would literally have taken all day. It would have taken like you know, several hours to run serially. If you want to keep up with continuous testing and true continuous integration, you really need to run your tests in parallel. Like you can't continue to run serially. It's no bueno. You won't get it done in time. It's why bother. However, when it comes to parallelizing your tests, there are several factors you need to consider. First factor you need to consider is your test environment. You need to make sure that the product under test, whether it's a web app or service API or whatever, can handle more than one test running at a time, right? You know, if here with DuckDuckGo, it's like anybody can you know, pop up the page and do a search. You can do however many searches in parallel. It's not a problem. But if you've got, let's say, like a banking application where you have user logins and that kind of thing, one thing you may need to consider is like, do I need to have a separate user for every parallel test thread so that there's no collision? Oh, right. That could be a challenge. Maybe not. Maybe you could have the same user login in multiple sessions. Who knows? It depends on your app. Another thing would be shared data in the system, shared state, right? If everyone's logging into one instance of your web app, right, and somebody creates a record and someone else destroys that record, ooh, that could be a problem, because now, you know, the test that was expecting that record to be there is gone. The test is going to crash. So you need to protect your data within the product. That could be as simple as, well, you spin up a Docker container for every parallel test that runs your product. It may be you have to carefully choose what tests can run in parallel and which ones can't. Just things to think about. Aside from the product and the shared data there, you also need to worry about the test automation being able to run in parallel. You cannot use global variables. You cannot use static variables. You know, you have to make sure that your test framework has mechanisms for running tests in parallel. You also have to make sure that you have the testing infrastructure to handle that scale. Your local machine can probably do a couple tests in parallel. Usually you find one test per processor or core is where it maxes out. You know, so if you want to do like 50 in parallel, now you have to use a big scale out tool. You need to use a grid, a cluster. So be mindful of those things. Parallel testing is its own talk. It's its own tutorial, for crying out loud. It's its own TAU course, you could probably say. Not a bad idea. We should probably do something about that. Anyway, here I'm going to show you how to do low scale parallel with pytest. Well, anytime you want to do parallel testing with pytest, there's a plugin for that. Pip Install Pi Test xdist, meaning distributed. Add this plugin. What this will allow us to do is to run tests in parallel if we add a command line option. Now, we only have one test, so running tests in parallel doesn't really help too much. What we're going to do is we're actually going to parameterize this test so that we can have multiple tests out of it. And we're going to do this kind of lazy. Don't judge. Import the pytest module into your search test or test search module here. And we're going to add pytest parameters. What we're going to do is we're going to, instead of searching just for pandas, we're going to search for multiple animals. So I'm going to create a list of animals. Oh yeah, no. Oh, come on, man. No, stop the autocomplete stuff. No, I just want to, there we go. Sorry about that. Let's search for panda, Python. Oh, shoot, I'm just going to copy and paste, make my life easy. Search for a bunch of different animals. Python, polar bear, parakeet, porcupine, parrot, pangolin, panther, platypus, peacock. All the P's, right? You can add any animals you want. You can add as few or as little. Then we're going to use those animals to parameterize the test. pytest mark parameterize. With pytest mark parameterize, we are going to name the arguments in the test function that we're going to parameterize. In this case, I'm going to pass in a phrase. And then you're going to give it a list of tuples or a list of the parameterized values. So in that case, it's animals. Now, the only thing we need to add to this is a phrase argument, and that's going to be a string. Now, anytime we see hard-coded panda, we're going to replace that with phrase. If PyTest parameterization is new to you, definitely read more about it on the docs or take my PyTest course on TAU. That'll give you a really good overview of the PyTest framework. Right here, for this purpose of this tutorial, we're just using PyTest, not so much teaching PyTest. Okay, so I've marked it with the parameter phrase, passed it in. Oh, one more place. Since this is part of a greater string, we can either do a concatenation, or we can use F strings for interpolation. And so I'm going to use an F string so you put the F in front of it, you have the curly braces, and inside the interpolated variable, which is phrase. So now when I run this test, if I were to run this just as a regular test, no parallelization, there will be 10 tests, and it's going to run each one at a time. I'm doing this headless to make it go a little bit quicker, but still, we're sitting, and it's kind of slow, right? Yeah, it's pretty dang slow. I don't like slow. I got to go fast. I'm like Sonic the Hedgehog. Oh, one of them failed. That's not good. Which one failed? Oh, I think I know why they failed. Let's quit out of this. Okay, so annoying thing. DuckDuckGo has some protections, you could say, where if it thinks that you're an automated bot trying to run searches, it'll freeze you. And one way it tells if you're an automated bot, if you're headless. So you can't do high scale parallel testing against it like that. So, or like repeated searches, like one after the other. So we have to make this headed. Sorry, folks. So there we go. Anyway, this should do the trick now. If it's headed, it doesn't think you're a bot. So you can see how long this is taking, right? Every test is only like 2 to 3 seconds long, but even just for 10 tests here, we have to sit and wait and make small chat while this is happening. And so ultimately it took 20 seconds. Now you'll be thinking, well, 20 seconds still isn't bad. Actually, 20 seconds isn't that bad compared to Selenium WebDriver. Selenium WebDriver, we'd be sitting here for like 2 minutes. But imagine if we had 100 tests. You know, that's 200 seconds. That's like 3.5 minutes. Imagine if you have 1,000 tests, 2,000 seconds. Do the math on that. Like all of a sudden, web UI testing becomes very, very slow. That's why we need to parallelize. What I can do is I can, now that I have pytest xdist installed, add -n for number. And I could run, let's say, 2 tests in parallel. And now you can see it go, boom, boom. It's opening up double browsers. It's having a good time. DuckDuckGo isn't freaking out because it's headless. Okay, boom. And so we nearly cut that time in half, down to 24 or down to 11 seconds. And we could do it even more. We could even try to do 10 in parallel. I have one of those new M1 Max. I've got like 8 cores or something crazy. My personal one is a 16-incher. It's got 10 cores. I've actually done it 10 times parallel. It's beautiful. It's absolutely beautiful. But just tune the parallel scale to what's appropriate for your machine. Another really, really cool thing with the parallel execution is that you can do parallel execution with cross-browser testing. So you know before how we had the cross-browser thing going. We can do that together with parallel testing to really, really speed that up. So let's say I have, I want 5 tests in parallel: browser, Chromium, browser, Firefox, browser, WebKit. So now it's going to run those 10 tests, the 10 parameterized tests against 3 browsers 5 times parallel. So we should have a total of 10 times 3, 30 tests running 5 at a time. So each thread will ultimately cram through 6 of them. Oops, sorry. The other browsers are popping up on my other window. That's why you're not seeing them right now. But it's just crunching through all these tests here. Oh, looks like one got frozen. Which can sometimes happen. The higher scale you run, you're more likely to see weird kinds of things in your environments, like browser freezes, like this one, or something sketchy happens. You know, something didn't time out right, like here. That one failed. But still, you know, you have to build in for things like that. You know, with our the super high scale test suite at my old company, you know, where we're running 50 to 100 times in parallel, we would automatically have failed tests rerun twice just to see like, hey, was that some weird Selenium fluke or some environmental thing, or is that a legitimate failure? And when we did that, it really helped with the reliability of our tests. You know, just getting more information, realizing, oh, well, that must have just been a fluke. Yeah, weird error message. The other 2 passed. We're good. So be aware of that. I mean, we demonstrated it here, but even still, 30 tests in 50 seconds. 30 web UI tests in 50 seconds, in less than a minute. Like 5 years ago, if you had showed this to people in my space, they would have lost their heads. They'd be like, oh my gosh, how did you do this? It's pretty incredible. So what I would do is I would look at why this thing went wrong. It timed out after 30 seconds. It couldn't find a particular element on the page. I would probably go in and try to rerun this a couple times. See, is this really a bug, or is this just some weird thing? I always favor like strong. It's always better to have a small set of really good bulletproof, reliable tests that actually deliver value than to have a large suite of flaky tests. So I would be looking in here. What are ways that we could try to harden this, to try to make it better? But I mean, there you go. You can do it. So we only have 15 minutes left. That's not enough time to go through the API testing. So what I'll do is I'll just kind of speak to the API testing instead of walking through it. And y'all can take that as a homework assignment. What can I say? So here is the guide for the API testing chapter in my GitHub repository. Now you might be wondering, Andy, why are you talking about API testing? I thought Playwright was a web UI framework. True, yes, but the Python implementation of Playwright includes embedded API call support. So just like you can get a page and you can start making interactions to the page, you can get a request context and start making request calls to whatever base URL that you have. Underneath the hood, I'm 99% sure it's using requests. Surprise, surprise, the most popular Python library there is, or at least one of them. But you might be wondering, okay, so why would we want API testing? If you test web applications, you find out very quickly, even with all the parallelization and the optimization and the smart waiting, web UI testing is still slow because you have to click and wait for things to load and stuff. APIs are much faster. You'll also find with end-to-end testing, you need to do a lot of things like authentication. You need to log into the app to get the credential before you can keep moving on. You need to do things like data preparation. Oh, I need 3 records in the database already. I need a loan application already in place before I can start doing testing on it. I need a user profile loaded. It's much more efficient to load and prepare data using an API rather than navigating through a web UI and clicking buttons and entering text and submitting, right? As we saw, seconds add up very quickly. So if you can replace a 3-second interaction with a 100 millisecond API call, do it. So what my chapter on API testing shows is how you can use web UI interactions together with API interactions to make very good, very efficient end-to-end tests. And to do that, the product under test is no longer DuckDuckGo. The product under test is a GitHub project board. So in GitHub, you can create project boards for yourself as a user, and you can also create project boards for a repository. And so what this chapter will do is it will show you how to use APIs with web UIs to test things on a project board. So to get started, you need to create a GitHub account, which I'm guessing if you're in this tutorial, you probably already have one. If not, you can go sign up. It's free. It's easy. You also need to create a user project for yourself, not a project attached to a repository, but a project for you as a user. And you need to go into the settings and create a GitHub personal access token. I've got all the instructions for how to do that here. Then what you do, you need to set up a bunch of environment variables for things like your username, password, your access token, and your project name. I include instructions on how to create fixtures, PyTest fixtures to read all that stuff in. And then, then there's a whole bunch of setup. So with your GitHub account, what you're going to need to do is you're going to need to log into the GitHub website as your user. And you're also going to have to fire API requests using that access token. So here I show you how to create or how to get a Playwright request context and automatically add authentication to it. So every request you have already has that token in it. Then I show you how to, write a pure API test where you're going to create a new card on your project board entirely through the API. And so you can see here, you build your resource path, you use that request context from Playwright you created, you call a get on your resource path, you do the same expect, you expect your response to be okay. And then from that, you can parse the data and get things out. Later on, I also show you how you can, so here you go. Here's a test where you create a card and then you make sure that card was created okay. If you're familiar with requests, it should look very familiar to you. I also show you how to write a hybrid UI API test, where in this case, what you do is you create a new card with the API, you log into the GitHub website through the UI, load your project page, you drag and drop that card to another column, you make sure that the card stuck to the column, and then you make one final call, API call to the backend to make sure that moving the card actually changed its column location. So that test is a bit more intense. You can see the full code of it here. But again, I've got the comments explaining what's doing. You make the calls here. You can see these are the Playwright calls to make an API right alongside with the Playwright calls to log into the UI. So I would say give that a try. It's more of an advanced kind of topic, but one that is really serve you well for API testing or for true end-to-end testing. Whew. So yeah, oops, sorry, go back. So everything, including the example code today, is in that GitHub repository I shared. And so I'll leave the last 10 minutes if anybody has any questions about anything, whether it's Playwright specific, PyTest specific, testing in general, or even anything about me.
Hey, I have a question.
Sure.
So I'm building a Flask app right now, and I've been using PyTest in there as I build. But from what I can tell, I could circumvent that aspect and go straight into this PyTest Playwright testing as I build, so I can avoid the specific PyTest. Is that what you would suggest, or does that even make sense?
So when you're saying you're trying to get around PyTest, what exactly do you mean? Do you mean like?
No, I'm not trying to get around it. I'm just saying as I build things, and the Pythonic way is to test everything. this
Yeah.
kind of takes the place of PyTest by itself.
I guess, yeah. I guess I would be careful not to say this doesn't replace PyTest. I would say this supercharges PyTest, right?
Right, okay.
Because we're still using PyTest to structure our tests, to run the tests, to give us the results and all that goodness. Like PyTest is awesome, right? We're still using fixtures. We're still using test functions. Playwright comes in as a library, you could say, that enables you to make really awesome browser and API interactions. And so you can do the end-to-end style testing of a Flask app. You know, if you're loading pages and doing things and having requests go left and right, you can exercise all those behaviors with Playwright through PyTest.
So as I'm developing, maybe do PyTest only test for some of the functions, but then as I get into the browser stuff, start adding Playwright. Yeah,
I would say, because you're essentially making two kinds of tests. There's a big difference between testing code and testing features or behaviors, right? When you're testing code, you are testing, an individual function. You're making sure it's parsing that string properly, or that it's adding two numbers correctly. You still need those tests. Those are what we typically call unit tests or white box tests. They're very important because they're super fast. They take milliseconds and they pinpoint errors very, very quickly versus, far up the chain. But at the same time, unit tests can't tell you, did your app load correctly, right? Hence, you need tests for behaviors, which are, when your app is deployed and you're making calls to it, or you're clicking or scraping, right? And so to develop both those kinds of tests at the same time you're developing the code in like a test-driven development kind of sense, is very helpful and very powerful.
Perfect, thank you.
No problem. Great question.
I've got another question. It's around CI/CD integration. So if I understand well, all I need to do with Playwright is just install it. It takes like 10 seconds to install dependencies. And if that's the case, I think this gives a big plus comparing to Selenium or Cypress. Because,
oh my goodness, yes.
They take more.
Yes,
what do you think?
Absolutely. Like I mentioned, easy setup is one of the advantages of Playwright. And this really hits home not only for when you're developing, but also when you go to a continuous integration environment. Because I mean, you could set up CI multiple ways, right? You could get Circle CI, you could get Jenkins, you can make GitHub actions, or maybe you're trying to pack a Docker container and send that out. Ultimately, whatever type of CI path you choose, whatever tools you take, ultimately somewhere you need to declare what your execution job looks like, right? Meaning, download all the packages, check out the repo, probably opposite order, check out the repo, install all the dependent packages, install anything else you need in that image, and then run the tests. And so with Playwright, with this Python project, what you would do is you would, git clone the repo. Then you would do pip install -r requirements txt, get all the dependency packages. Then you would do Playwright install, which would give you your browsers, right? And then you would just say pytest run, or python-m pytest tests to run your Python, or you would just run your tests, sorry. If you were doing something like Selenium, you'd have to make sure that you install Google Chrome or Firefox or whatever. Then you'd have to install those stupid Chrome. Sorry, I shouldn't say that. You'd have to install the Chrome. They're not stupid. You'd have to install the extra WebDriver executables for Chrome driver and Gecko driver and all those things. Then you'd have to export a path, so that becomes very clunky. And with Selenium WebDriver, you have the full browser process. You have that executable. You hope and pray that you don't blow out the resources on whatever CI thing you're doing. Whereas Playwright has a much smaller footprint, so it's easier to set up. It's easier to integrate. It's headless by default, which is another thing. Selenium is not headless by default. You need to explicitly tell it. Whenever you run a CI, you always want to run headless. Why? Because there ain't nobody there to see the dang thing go up. Headless more efficient. I've even seen issues where I've tried to create GitHub actions where I run tests and it's I forget to make them headless. and then they blow up, and I'm like, what's going wrong? As soon as I make them headless, they're fine. So yeah, in fact, one thing that I probably ought to do, maybe I should add a GitHub action to this repo as an example. But anywho, yes, opinions reign. Playwright, very easy to set up in CI. Arguably, in my opinion, easier than Selenium. Cool. Do we have
I think I
any
got
other
lost.
questions?
I got lost as you're answering that question. Are you saying that you could run this on a remote server, headless?
Oh yeah. I mean, well, so
Like an
that's another
Ubuntu,
question.
an Ubuntu VM?
I mean, yeah, you could run Playwright test wherever, right? Now, remote control of that is a different question. You know, are you saying like from my Mac here, can I launch tests over there on some Ubuntu VM? The answer to that is yes. Do I know exactly how to do that off the top of my head? No. Would I want to do that? Probably not. When it comes to a CI environment, I would probably just want to have like some CI server take care of that for me, you know. But I do know that you can have remote browser sessions with Playwright because they operate on the dev protocol, so you can farm it out. I know that Playwright does support Selenium Grid, so that if you already have a Selenium Grid that you're running, you can farm out requests there. Though I have heard from the Playwright team that is suboptimal. If you want to do a scale out like that, they recommend a DIY effort using like dev protocols, kind of build your own grid. It'll be a lot faster. Have I done that yet? No. I'm waiting for someone to make that an open source project. You know, there are also vendors out there like Sauce Labs and Lambda Test doesn't do it yet. Who's the other one? Browser Stack, I think. I don't know. There are some vendors like that now support Playwright. Apple Tools, where I work, we support Playwright with JavaScript in our ultra-fast grid. So that if you write Playwright tests, you want to do visual snapshot checking, which arguably is better than traditional cross-browser testing because it's faster. It's all that, you know, you can use Playwright for that. I'm begging them to add Playwright Python support for that. If you want that, please hit up Apple Tools on Twitter and be like, hey, we love Andy's presentation. Let's add visual testing to it. Can you help us out? Just saying, you know. Yeah, like if I'm thinking about like basic remote execution, I would be like, just, you know, it would be on a remote machine, but would be launched locally in a CI environment like that. Hope that makes sense.
And I have a question related to Playwright, but not necessarily testing. I went to the session yesterday that introduced it, and I was kind of amazed by Playwright. That's why I'm here today.
I know, right?
But thinking about some usage for web scraping, but then I tried to do a test with it after the meeting, and I kind of got lost of trying to find items that are downloaded or gotten, but not necessarily shown on the screen. Would you like the specific instance would be like blobs that are loaded posts.
Yeah, so I haven't done a whole lot of that kind of thing with Playwright. I mean, the majority of my Playwright usage has been targeted towards test automation.
Right.
So like what I would say is this, like if you ever get stuck with Playwright, first of all, go to the docs. So like here I've showed the docs. They have really helpful docs. They also have like the full API documented. Then if you can't get it from the docs, join Playwright Slack. They are very, very good about answering your questions. Because I've had questions. Yes, I've had questions quite a few times. And Max Schmidt is the Microsoft engineer. He presented yesterday with Andre. He's the one who primarily works on the Python implementation. I've also had Pavel Feldman, who is the overall project lead. He's answered me a couple of times. We go back and forth. We're friendlies. If there's like some very specific thing that you're unsure about, just ask in the channel. Somebody will pipe up within a day. And if it's something that Playwright doesn't support, that's a great way to kind of put it on their radar because Playwright is actively being developed. They have a team of, I believe, like 6 engineers. I think they're trying to hire a developer advocate. I don't know if they ever actually found someone yet. I know they had talked with me about that to try to find somebody for that role. I'm at Apple Tools, so I'm like, yeah, I'm good where I'm at. But they're an awesome team. I love what they're doing. And they're really cool to talk with. They're really helpful. And they're popping out new releases like every month or so, I think. And so, I've requested things that they've been like, oh, okay. I've opened issues against some of their docs that they've gone and fixed. And so it's like, if there's something that you need and you and other people also need it, or it's really valuable, they'll be like, yeah, we'll add it, or they'll tell you no, and they'll tell you why, and you just cry river. I don't know. But at least they have that feedback loop is what I'm trying to say. And they're open to delivering value to the community.
That's awesome.
Thank you all for joining. You probably know by now, I love testing and automation. If you want to keep in touch, I'm always down to talk about these things. Hit me up on Twitter @AutomationPanda. And then also, if you want to learn more about other kinds of testing things, please go to Test Automation University.